Okay, today we're going to talk about unit rates. Okay, so if you don't have your notes out, go ahead and grab them out. All right, we have a couple of vocab words, so grab your notes, your binder. Okay, green on the left, notes on the right, and be ready to go. If you haven't put your notes into your binder as of yet, they're your new notes. All right, so make sure you do that. Okay, hopefully that's given you enough time, so here we go. All right, so unit rates, we're starting a new chapter. So unit rates is kind of the basic part of this chapter. It's where it all begins, so let's talk about this. So the very first word is actually just rate, everyone. Okay, so here's what a rate is. It's a ratio that compares two quantities with different kinds of units. All right, a ratio that compares two quantities with different kinds of units. All right, so for an example to put in your little box on the right side, a rate would be something like having 4 students to 2 desks. 4 students to 2 desks. That would be a rate. Okay, obviously a ratio is something like having just 4 to 2, but as soon as you put the units there, students and desks, that makes it a rate. All right, so if that's a rate, I want to talk about our next word. Our next word is unit rate. Everyone? Okay, unit rate, here's what your book says. It's a rate that is simplified so that it has a denominator of 1 unit. So remember, a denominator on, let's say, a fraction is the bottom number. So the denominator needs to be 1. All right. So for example, the 4 students for 2 desks would actually be simplified. If it was 4 over 2, it could be simplified as 2 over 1, or in this case, 2 students to 1 desk. Okay, and you're going to see this a lot in this chapter. The other way to say 2 students to 1 desk would be 2 students per desk. Okay, and that's a unit rate. You'll see the word per a lot. Okay, meaning for 1. 2 students for 1 desk, or 2 students per desk. Okay, so go ahead and put your notes away. Go ahead and grab your book and turn to page 13. So it's actually, we're going right back to the front of the book. We're starting with chapter 1 here, so page 13. Okay, on page 13, let's go ahead and let's take a look for these examples. Let's start with number 3. Let's look at problem number 3. So number 3 says 45 5/10 or 45.5 meters in 13 seconds. Oops, seconds. All right. So here are the steps on how you find a unit rate. All right, so here's what we're going to do. The very first step is you're going to go ahead and you're going to take the one part of this rate, because that's what they gave us. They give us a rate. We're going to take that first part there, and we're going to go ahead, and that's going to become our numerator on this problem, 45.5 meters. Okay, and then the second step is you're going to go ahead and take the second piece of information, the 13 seconds in this problem, and that's your denominator. Okay, so it's 45.5 meters in 13 seconds, written like a fraction. Now, step 3, here's what you're going to do. Remember that we need a denominator of 1 for it to be a unit rate. So this would be 1 second. Okay, that's what makes it a unit rate. So you ask yourself, just like a normal fraction, how do we get from 13 to 1? Well, it's like reducing. We're going to divide by 13. And of course, guys, like any other fraction, if we do that to the bottom, we divide by 13 on the denominator, we're going to go ahead and divide by 13 on the top, or the numerator part. So, and of course, we're just looking at the numbers right now when we're doing the math. So it's 45.5 divided by 13. Okay? And so that is going to be something that we're going to need to solve. So 45.5 divided by 13. Excuse me. So here we go. Let's go ahead and let's take a look and let's estimate here. We're going to go 13 into, let's start with the 45, and I'm going to cover up the last digit of each and say 1 goes into 4 without going over 4 times. Now probably what I want to do right over here is I want to try that out, little guess and check. Remember, we're just estimating, so 4 times 3 is 12, carry the 1. 4 times 1 is 4, plus 1 is 5. Too big. So let's go down 1. 13 times 3, that's 9 and 3. Okay, 39 works. So 13 goes into 45. I'm going to go ahead and put the 3 above the 5. And of course, the 3 times 13 is 39. I'm going to go ahead and subtract. Make that a 3. So I borrow while I'm subtracting here. So now we say 15 minus 9 is 6. And then 3 minus 3, of course, is nothing. So I'm going to go ahead, bring down my next number. And remember, for right now, we're going to ignore the decimal point on this long division. So now 13 goes into 65. I can do the same thing. I can go ahead and cover up and take a look. 1 goes into 6 times. So we can try 13 times 6. 6 times 3 is 18. Carry the 1. 6 times 1 is 6 plus 1 is 7. 78 is too big. So we already have 13 times 4. Let's try 13 times 5 though. 5 times 3 is 15. Carry the 1. 5 times 1 is 5 plus 1 is 6. Perfect. So 13, I bring the 5 up here. 5 times 13 gives us exactly 65. Since we're done, we bring, because the 3 is over the 5 and this 5 is over this 5, we should be able to bring the decimal point straight up and we have our answer. So here we go. 3.5, and then we're going to use the same units. So 3.5 meters, okay, in 1 second. So if that person travels 45.5 meters in 13 seconds, we can say that they, on average, travel 3.5 meters for 1 second. Now, on your homework tonight, I'm going to actually want you to do a step 4. All right, and here's what it is. I want you to get used to putting it into a final answer. All right, so when you see it on a test, you'll know exactly what it means. And here's what all I want you to do. You're going to go ahead and put the 3.5 meters, but instead of putting it in fraction form where the line is, and of course with the 1, we're going to use the word per. So instead of 3.5 meters over 1 second, we're going to put 3.5 meters per. Now listen, the per already is meaning the 1, so it is per second. And there's our answer to problem number 3. Okay, so not all of them will have a really long division like this. Okay, this one did, obviously, so some of them might be a little more mental math. So here's what I would like you to try. I want you, okay, this will take probably a little while to reduce, so I'm going to go ahead and I want you guys to try number 4. Number 4, I'll leave the steps up here. You have the steps on your table, on your desk there in your notes. So go ahead and follow each one of those steps. All right, and I will go ahead and give you guys about a minute. All right, so number 4, go. Okay, go ahead and put your finishing touches on number 4. All right, so let me go ahead and give you 30 seconds. I want you to share the answer, but of course, guys, I want you to make sure you're sharing the correct answer in the correct form, okay, when you do this. So make sure when you share with your neighbor, do that. All right, so 30 seconds. Go ahead and turn to your neighbor and share your answer. Go. Okay, so let's take a look at number 4. All right, so on number 4, you guys should have had $7.40 for 5 pounds. So here's what you're going to do. Okay, I'm going to go right through the steps. Step 1 is write the first unit here, the $7.40 as a numerator. The second number here, the 5 pounds. Okay, I'm going to go ahead and write as my denominator. All right, and to find the unit rate, I need to go ahead and I'm going to make sure that the 5 pounds become 1 pound. Okay, because I'm already thinking it needs to be so much money per pound. That means per this pound right here. So here we go. I need to divide the bottom from 5 divided by 5 gives us the 1. I'm going to go ahead and do the same thing to the numerator. All right, so 740 divided by 5. I'm going to come over to the side here. 740 divided by 5. So 5 goes into 7. Okay, that's what we're going into. 5 goes into 7 one time. 1 times 5 is 5. I go ahead and subtract. 7 minus 5 is 2. I'm going to bring down my 4. 5 without going over goes into 24 4 times, because 4 times 5. Notice how I put the 4 over this 4 that I brought down. 4 times 5 is 20. When I subtract, 4 minus 0 is 4. And I bring the last 0 down, and I know that I can go 5 into 40 exactly 8 times. And that 8, I brought the 0 down, so I'm going to put the 8 above that 0. 8 times 5 is exactly 40 with no remainder. The decimal point comes up, and I have my answer of, and the only units up here is a dollar sign, so $1.48 over 1 pound. Now, like I was saying, we still have step 4, and that is I'm going to go ahead and take this and write a final answer. And that final answer is $1.48, and instead of writing 1 pound, I'm going to put per pound. And there is our answer. So hopefully if you did not get that, you wrote down what you missed out on. Okay, so here's the next kind of problem. We're going to take it up a notch. We're actually going to use this skill to solve a real life problem. All right, so here's what I want you to do. Let's go ahead and let's take a look at page 12 to the guided practice part. Okay, so just look to your left there. All right, on page 12, let's take a look at number 2. Okay, number 2 says, so make sure you're on page 12, number 2. I need everyone looking at this. So here we go. Number 2 says, after 3.5 or 3.5 hours, Pasha had traveled 217 miles. If she travels at a constant speed, how far will she have traveled after 4 hours? Okay, so there's a couple of different ways you can do this, but for the sake of using unit rates as a tool, this is how we're going to do it today. All right, so here's the very first thing you're going to do. All right, the very first step is you need to write down, okay, the 2 pieces of information that are related to each other. Okay, and what we're going to do is we're finding our rate. That's what we're doing. So step 1 is find your rate in the problem. Okay, and so if you take a look even up at here, right, we have 740 for 5 pounds. Notice how they're different units. Okay, this one was 45.5 meters in 13 seconds, meters and seconds. Okay, dollars and pounds. Well, that's because units have two different types of, most of the time they have two different types of units. So if I reread that, after 3.5 hours, Pasha had traveled 217 miles. And there you go. All right, so what we have is, I'm going to put the 217 miles on top. And it took her 3.5 hours to travel that far. So what I did is I found my rate and I wrote it as my ratio. Or I'm sorry, my rate. I wrote it as my rate. All right, I found my rate and wrote it down. Okay. Now, at this point, that's the only thing so far that's different from our previous one. So that means that after I wrote this down, I'm going to go ahead and go to our next step, and that is I need to reduce. So we'll just call this in this problem, I'm going to reduce. Remember, we're finding a unit rate, so I need this to be for 1 hour. How far does she go in 1 hour? Or how many miles per hour? That's something that you guys, I'm sure, have heard before. So here we go. To get from 3.5 to 1, I'm going to divide, and don't freak out because it's a decimal, I'm dividing by 3.5. I'm going to go ahead and do the same thing to the top. And then that's going to give me how many miles that she traveled it per hour. So here we go. I'm going to go over to the side and solve that. So 217 divided by 3.5, 3 and 5/10. Okay, so here we go. Now, it might have been a while since you've had a decimal in the divisor, this outside number, so that's why I want to take our time here. So we take the decimal, we have to get rid of it. You can't have a decimal in the divisor. So we're going to move it over one time to get rid of it. So we made 3.5 or 3 and 5/10 into 35. Now you just can't do that without doing something else. And here's what we're going to do. We're going to take the 217 and move it over, the decimal over to the right once as well. So if I move it once on in the inside, I'm going to go ahead and move it once in my on the inside. Once on the outside, then move it once on the inside. Okay, so I move it once on the divisor, move it once to the right on the dividend. If I have that little loop there with an extra space, most of you probably know, of course, it's 0. So what I have is I have 35 into 2,170. All right, now 35, I don't want to go into 21, but I do want to go into 217. Okay, so 217 divided by 35, I'm going to do the exact same thing I did last time. I'm going to cover up the last digit to estimate. All right, if we're going to guess and check, I need to estimate first. So 3 goes into 21 7 times. So let's try 35 times 7. 7 times 5 is 35. Carry the 3. 7 times 3 is 21 plus 3 is, that's too big, 24. So let's try 35 times 6. 6 times 5 is 30. Carry the 3. 6 times 3 is 18 plus 3 is 21. All right, so what we have is we end up having 210. 35, I put the 6 over that last digit here, the 7. Okay, and that is 210. When I subtract, 7 minus 0 is 7. Bring down the 0. And look at that. If you don't already recognize that, 35 goes into 70. I know 35 times 2 is 70. So 35 goes into 70 2 times. So remember, we brought the 0 down, so that's what the 2 goes above. So 2 times 35 is 70, no remainder. So what this is this is 62 miles per hour. Okay, now that is our unit rate, but watch. That's not what the question's asking. The question asks on number 2, if she travels at a constant speed, how far will she have traveled after 4 hours? So watch this. We take our unit rate. So everything we've done so far, besides taking the words out of the, taking the rate out of the words. Other than that, everything else we've done so far is exactly the same. So here's what we're going to do. We're actually going to add on step 3. And this is where it really changes. I'll put a little star by step 3 because this is where it changes from here, or I should say from up here to here. If we want to find out how far they go in 4 hours, all we need to do is set up another equal equation, another rate. Okay, we have our unit rate. Now we set up our other rate. Notice how I put hours on the bottom because that's where that is. Okay, so the same thing as I did up here. How do I get from 3.5 to 1? I divided by 3.5. But down here I need to know, how do I get from 1 to 4? I multiply by 4. Now some of you guys may have already known that before even setting this up. And so I'm going to do the same thing to the top. So ultimately we're multiplying 62 miles times 4, or 62 times 4. So I'm going to come over here, multiply it out. 4 times 2 is 8. 4 times 6 is 24. So I end up with 248 miles in 4 hours. Okay, now this is step 4, and this is very important. The question says, how far will she have traveled after 4 hours? She does not travel 248 miles over 4 hours. That's not what the answer, the final answer is. The final answer, we use this as a tool. The final answer is right there. It's our numerator. She travels 248 miles. So make sure that when you write your answer, you're answering the question. You're not giving a fraction. That's not what we're looking for. We're using the fraction to find the answer, but there's the answer. Okay? So, again, we write our rate. We reduce it to a unit rate. Then we take our unit rate and answer the question in the book by setting up. It asks about how far does she go in 4 hours, so we set up a new equal fraction, okay, or a new rate, and put the hours next to the hours, the miles next to the miles. Since they're giving us 4 hours, that's where I put the 4, and then we just solve our fraction. We just solve for a new rate. Once we get that rate, answer the question, which is 248 miles. Okay, so here's what I want you guys to try. I want you guys to flip back to your homework for tonight. Take a look at problem on page 13, problem number 8. Okay, you're back to page 13, problem number 8. All right, so I'm going to go ahead and give you some time to do that. Give you approximately 1 to 2 minutes to try out number 8. I know you have to read it and then write it all down. There's a couple of steps involved. So a couple of minutes. Go ahead and try that. Go. Okay, guys, go ahead and turn your neighbor 30 seconds. Go. Okay, so here we go. Problem number 8 says, Kinji buys 3 yards of fabric for $7.47. Then he realizes he needs 2 more yards. How much will the extra fabric cost? So it's talking about the extra 2 yards. How much is 2 yards going to cost? Well, it's a very similar problem. So what we're going to do is we're going to go ahead and write our rate here. And we're going to find the rate, and it's $7.47 for 3 yards. Okay, dollars on top, yards on the bottom. Okay, now we're going to find the unit rate. So I'm going to find out what 1 yard is. How much money is it per yard? So here we go. I'm going to divide by 3 here. So I need to divide the top by 3 to give me that price. All right, so 747 divided by 3. The nice part is there's no decimal in the divisor. So 3 is going to go into 7 without going over 2 times. 2 times 3 is 6. Subtract, we get 1. Bring down the 4. 3 goes into 14 without going over 4 times. Notice how I put the 4 above this 4 that I just brought down. 4 times 3 is 12. Subtract, 4 minus 2 is 2. Bring down my 7. 3 goes into 27 exactly 9 times. There's no remainder, so I bring the decimal point up. So it's $2.49 per yard. So of course, if I want to find out it's $2.49 for 1 yard, I need to find out how much it was. What does the question ask? It says, then he realizes he needs 2 more yards. How much will that extra fabric cost? So how much is 2 yards going to cost? Well, obviously we multiply top and bottom by 2, and that's going to give us our answer. So $2.49 times 2. 9 times 2 is 18. Carry the 1. 8 plus 1 is 9. 2 times 2 is 4. Okay, because we're multiplying, right? Decimal is 2 digits to the right of the decimal, so 2 digits here. And we have $498. I'm sorry, 498. It's $4. That's why decimals are so important. $4.98 for 2 yards, which means how much does it cost for the extra fabric? $4.98 is our final answer. Okay, just the $4.98. Okay, I do have a quick reminder. There's questions on tonight's homework that's going to ask you to compare certain things. For example, number 6 might ask you, it shows you all of the swimmers and their times. It asks you to compare like who was the fastest. So what you're going to want to do on problems like that is you're going to want to find every single one of their unit rates, and then you need to compare their unit rates. Okay, so that's what you're looking to do on problems where they want you to compare. Find everything, all of their unit rates, and then compare. All right, so the rest of the time is yours. Go ahead and get started.